All right, so let's go ahead and start our selection sort. So selection sort. So for these next videos and for selection sorting these next videos, I'm not actually going to do any coding. That's your job. So what I'm going to end up doing is just putting, you know, just describing how these algorithms work, these sorting algorithms. Now, there's a lot of different ways to sort things, okay? Some are good, some are not so good. Like the ones we're learning today are not so good. To get the really good ones, you really got to understand recursion. But these ones are, but some of these are okay. And then, of course, there's very terrible ones that I go over in 2168. But for the most part, these are, these are what you'd be expected to know, especially bubble sort, which we'll learn next. So selection sort is fairly straightforward. Okay? So suppose we're given an array, and I'll skip the whole brackets. So suppose we're given an array and we want to sort it. So 8, 2, 1, 7, 3, 5, 4. So what else do I have? 6. So 1, 2, 3, 4, 5, 6, 7, 8. Right? I like to sort arrays of size 8. So the idea here is that this is an unsorted array. We really want to turn this into a sorted array. So the way selection sort works is it's fairly straightforward. It says, well, if we're going from smallest to largest, right? Smallest over here, and then you're going to largest, okay? Then this guy over here, this one ought to be this index over here that 8 is currently occupying. It needs to hold the smallest element in the array. Okay, so we got to just find the smallest. So what we'll do is we'll find the smallest element and put it here. Okay, then we'll go over here and find the second smallest element and put it in here. Or, well, easier way to put it is smallest element is now over here. So from this to the end of the array, let's look for the smallest element and put it in here. That will be the next smallest element. Okay, so then we've got the two smallest elements out of the way. Then from here, we'll go ahead and say, let's look for the smallest element in this remaining section and put it in here. And that's the appropriate element. So let's see that in action. Okay. So over here, let's go ahead and just figure out let's go and look through all the elements in the array. Okay, and figure out which one of these is the smallest. It's easy for us, but the computer will do it like this. So 8 is currently the smallest, 2 is the smallest, 1 is the smallest, 1 is the smallest, 1 is the smallest, 1 is the smallest. I'm done now. I've looked through every element of the array. I determined that 1 was the smallest element in the array. So I need to move 1 over here because it's the smallest element, so it should go to the front. Okay? So how do I do that? Well, we'll use that swap function we just wrote to swap 1 and 8. Right? So we'll swap those two elements. We'll swap what's at the front with the smallest item. So we'll swap them. And now we know that this item over here, 1, is sorted. Okay? So now let's go to the, so we've got that taken care of. Now we need to go and look for the next smallest item. So what we're going to do is we're going to look through the array starting at here. We're not going to start at here because we've already locked this guy into place. We found the smallest item, put him into here. Right? So now I've got to examine all the elements over here and find the smallest element in the array. Right? So 2 is the smallest, 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 2 is the smallest. So we've determined that 2 is the smallest. So what we're going to do is that we're going to move 2 into this location. I mean, it's already there, right? So that seems a bit silly, but just to make, for simplicity's sake on the algorithm, it's essentially just going to swap with itself, which means it doesn't do really much of anything, but essentially 2 gets locked into place. Okay, so 2 swaps with the location of 2. Get that guy locked in. Now let's go ahead and look at the remaining. So let's look for 3. Or sorry, let's look for the next smallest element, which we can see is 3. So 8 is the smallest, 7 is the smallest, 3 is the smallest, 3 is the smallest, 3 is the smallest, 3 is the smallest. We're done with the array, so we should swap 3, this item, into this location. So one of the things you're going to have to do is you're going to have to keep track of 2 things. You're going to have to keep track of not only what is the smallest, well, you actually don't have to keep track of 2 things. You've only got to keep track of 1 thing, but it's not the element. It's the index of the smallest element you got to keep track of, right? Index of the smallest thing I've found so far. 3, then we go over here. So 7 is the smallest, 8 is the smallest, 7 is the smallest, 7 is the smallest, 5 is the smallest, 4 is the smallest, 4 is the smallest. The smallest item we found was here, so we swap it with 7, and then 8, 5, 5. So 5 is the smallest, swap it with 8. 7 is, so now 8 is the smallest, 7 is the smallest, 6 is the smallest, put 6 over here. Okay, and then we can say 7 or 8, 7 goes here. And then when we get to the last element, well, it's the only item remaining, so we don't have to bother. I mean, and since it hasn't been put anywhere else, it has to be the biggest item. So selection sort simply says, let's go ahead and look for the smallest item and that we have left to sort and put it in our array. It's a I mean, it works. It makes sense, and it's pretty logical. The problem with it is that, as you'll learn in 2168, it takes an absurd amount of time to sort something that's partially sorted. It essentially has to make, right? We saw that with 2 and with 7. Basically, it had to go and essentially just figure, make sure that 2 and 7 were the smallest and then swap it with itself, which is a bit silly. But it makes sense why it has to do that. But this is selection sort and it's named so because we are selection sort. It's named so because we select the smallest element and move it to the front of the array.